Lesson 3.3 talks about simplifying algebraic expressions. So what we have been discussing as we have covered both days of this lesson is looking for like terms. And we said in class that how you identify like terms is if the term has the same variable with it. So if they both have x's, they both have y's, or if they are both constants, meaning just a number, you can put together those like terms. We've also talked about the signs, the addition, subtraction, knowing when to add or subtract. And we always want to use the sign that is directly in front of the term. So let's start with example 7, question A. If we look at this, we have 3 terms to begin with. We have 8/10 x plus 4/10 x plus 1/10 x. All 3 of these terms are like terms because they all include the same variable. So what we can do is we can just go ahead and go through and add the coefficients. Again, the coefficient is the number value in front of the term. So if we go from left to right, 8/10 x plus 4/10 x would give us 1 and 2/10 x, plus 1/10 x would give us 1 and 3/10 x. So we were able to take those 3 terms above and simplify them into just one simplified term. Now at this point, this is as far as we can go. We can't solve for x when we have an algebraic expression. So our coefficient is 1 and 3/10, x is our variable. Let's move on and look at another example. Let's skip through a few of these. Let's look at example 8, part A. If we look at this, our directions are telling us to simplify the expression. To begin with, we have 4 terms. So we need to look for like terms. First pair of like terms that we see are 5m and 3m. Notice the sign directly in front of the 3m, that's an addition sign. So that means we're going to add those together. So we would add our coefficients, 5 plus 3, which is 8. Bring our variable down. Then we need to see if we have any other like terms, which we do. Our constants would be considered our like terms. Notice I'm underlining those 2 times to show that those are the terms that I'm pairing up. Notice in front of both the 7 and the 2, we have both addition signs, so that means they're both positive. 7 plus 2 is 9. 8m plus 9 would be our simplified algebraic expression. Looking at another example, let's look at part B. So notice in part B, we have fractions. Notice some of our fractions have different denominators, and we also have some subtraction. Now we talked about in class, start looking at your like terms first before you start finding common denominators, because you don't always need to. So let's start with our B terms. I have 3/8 B, and I have 1/8 B. So my like terms already have common denominators. So I don't have to go through that extra struggle and having to work through that and the process as well. Now we also need to pay attention to the signs in front of the terms. Notice 1/8 B has a subtraction sign in front of it. So we're going to jump and we're going to do 3/8 B minus 1/8 B, which gives me 2/8 B. We'll come back to that in a moment. And then let's look at our other like terms. We have here, we have constants, we have 2/3, and we have 1/3. Notice the sign in front of the 1/3 is subtraction. So we're going to do 2/3 minus 1/3, which leaves us with 1/3. Now we said in class that 1/3 was positive, so I know that I'm just going to drop down an addition sign. We're not done completely. If you notice the 2/8 B, that's not in simplest form. So 2/8 can be simplified to 1/4. And now my simplified expression is 1/4 B plus 1/3. Let's look at another example. I think we're going to skip this one, and we're going to go to example 9. Notice here we have 2 different variables. So we start looking at this the same way we did the previous examples. Find your like terms. So we could start with 5y and 2y, addition signs in front. So we just add 5 plus 2 is 7. That gives me 7y. Go to your x terms. We have 3x plus 2x, that gives me 5x. Again, we have said in class how I have my answer written on the board. That would be acceptable at this point. By the time you get to high school, it would not be. Because if we have more than one variable within an expression, we want those variables arranged in alphabetical order. So it's just good to know that in the future, what I'm writing in the red is going to be your answer. Again, at this point, I take either of them. Right now, we're just focused on simplifying the like terms. Let's look at one last example. Let's look at problem number 11. We're going to start off doing the same thing, finding our like terms. So I'm going to start with my x's. Notice in front of the 2x, there's a subtraction sign. So this is 3x minus 2x, which leaves me with x. And then if you go to your y terms, notice my 2y, look in front of there, there's an addition sign. In front of my 3y, there's subtraction. So this becomes 2y minus 3y. If I wanted to, I could do add up, and that becomes 2y plus negative 3y. Well, positive and negative, we actually subtract. So 3 minus 2 is 1. That would give me 1y, and it's going to be a negative. My final answer would be x minus y. You could also write this as x plus negative y. If I were to use add up, if you look at what I wrote first, x minus y, if I apply add up, it turns into what I have below. So either one is fine. We also said in class that you could write coefficients of 1 in front of each of these variables, and that would be correct as well.